Paper 2, 2018, question 1. So I've got some experiments with some different concentrations of hydrogen peroxide, which is breaking down to make water and oxygen, and measuring the volume of water in each to start off with, the temperature and the catalyst. So the temperature is staying the same, the amount of water in the mixture is staying the same, so concentration and temperature is staying the same, but the sort of form of the catalyst, whether it be lumps or powders, changing, and the concentrations of the initial hydrogen peroxide are changing. So let's have a little look. Explain in general terms how a catalyst increases the rate of the reaction. It provides an alternate route to the reaction, and in doing so lowers the activation energy. Label a line on each experiment number. So what have I got here? I've got the initial one for experiment number 1. In experiment number 2, everything stayed the same, so concentrations stayed the same except when using a powdered catalyst. That will mean that the reaction will go faster, but the amount of products, because the amount of reactants is the same, will be exactly the same as well. So it's going to reach that line, but it's going to reach that line quicker. So it'll go up steeper, but end up at the same amount of volume of oxygen produced because the amounts of reactants are the same. So that's for experiment number 2. Experiment number 3, it's going to go at the same speed as experiment number 1. So it's going to reach the maximum amount of product at the same time here, but it'll go more shallowly because it'll produce more slowly because you've got lumps of catalyst and you've got a lower surface area. Explain in terms of the collision theory, increasing the concentration of hydrogen peroxide, the particles are closer together, so you'd have more successful collisions, more frequent successful collisions. Successful collisions would happen more frequently because the particles are closer together.